Alright, today we are going to look at using trigonometry to find missing angles in right triangles. Okay, so the first step in this process is the same first step as we've been doing. With respect to whatever angle we're talking about, we're going to label the sides. So in this case, or in all of these cases, our angles are the variable. But we can still say, well, with respect to this angle, 15 is the opposite side, 24 is the hypotenuse. So, which trig function am I going to be dealing with if it's opposite and hypotenuse? Sine, right? So, sine is opposite over hypotenuse. So, our setup is actually still the same as well. We're going to say sine of the angle. In this case, the angle is x. So, sine of the angle equals opposite over hypotenuse. So, equals 15 over 24. So, we need to get x by itself, right? We need to solve this equation for x. So I have to undo the sine function somehow. So it's not division because we're not multiplying sine times x. We're taking sine of x. So we need some way to undo that. Just like multiplication undoes division or addition undoes subtraction. What we can do is take the inverse sine of both sides of the equation, right? So what I'm going to do, okay, if you looked on your calculator, inverse sine is that sign with that little, it looks like a -1 power. It's not actually a negative first power, but that's what it looks like. That's just our notation for the inverse. So I'm going to do that to both sides of the equation. I'm going to take the inverse sine of both sides. So on the left side of the equation, inverse sine of sine cancels out. Okay, it's just like multiplying and dividing by 2. So what we have, and we have x by itself now, equals the inverse sine of 15 over 24. So this we can put into the calculator. If you press the second button and then sine, you will get inverse sine. Okay? It's the same process on these red calculators as it is on our graphing calculator. So it's just second sine, and you will get inverse sine. Then you can put 15 over 24 in. Now again, we do still need to make sure we're in degree mode, even on these red calculators. Now the red ones are a little nicer because their default mode is degree mode. Okay, so you can actually check from the home screen. On the bottom left, you should see a little DEG on the red ones if you're using one of those. All right. So, what do we get when we put this in the calculator? 38.7 degrees. Okay. Now, I did mention this maybe 2 days ago, very briefly. On all of these problems, x is the variable, but it is also very common to see Greek letters as variables for angles. So we could see a theta in there, or we could see an alpha in there, or we could see a beta. Okay? It's common to see Greek letters as variables. So that doesn't change anything, right? All that is the variable. Okay? So just don't freak out if you see a Greek letter at some point as the variable for an angle. Okay? I mean, the process is still exactly the same. It's just they denote the variable different. All right? Questions? That's it. It's not coming out. So do we want to do another one or two together?
Are we going to use sine on all of these?
No, it's not always going to be sine.
How do you know if it's going to be sine or not?
We label the triangle.
I wasn't here yesterday.
Right. So, with respect to our angle, we label the sides. So, 8 would be the adjacent leg here. 11 would be the hypotenuse. So, what trig function deals with adjacent and hypotenuse? cosine. So we would set this up as cosine of x equals adjacent over hypotenuse. So equals 8 over 11. Then, to get x by itself, we're going to undo cosine. So I'm going to take the inverse cosine of both sides. That cancels these out. We get x equals the inverse cosine of 8 over 11. And that then we can put into the calculator. What is it? 43.3. So yeah, that's 43.3 degrees is the measure of this angle. That's it. Today we're finding missing angles. Yesterday was missing sides. Today is missing angles. Okay. Do we want to do a couple more, or think we can try some?
Wait, how do you do these?
So katsoa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent.
So it would be x equals tan -1 of. No, wrong switch. X equals to -1.
I think he's an attorney.
Yeah, if it says domain error, you probably chose the wrong trig function.
Oh, I mean, if they say something, oh.
Alright, here are the answers to 3, 4, 5, and 6. Good. Not harder, just maybe a little longer. I mean, like in the next couple, we're going to solve for all the missing sides and angles. Bless you. So it's just maybe for one problem doing this type of thing a couple of times. So any questions on these ones? Alright, then let's take a look at the bottom here. So the directions just say solve each triangle. Right? If you ever see something like that, what that means is find all the missing pieces, right? All the missing sides and angles. So I need to find one missing angle and two missing sides in this case. Well, first, it's probably going to be pretty easy if we know two angles to find the missing one. Right? In this case, I can just say, well, all three angles will have to add to 180. So angle A is going to be 180 minus 90 minus 39. Give me 51. So we already have one of our missing pieces. Now, we need to solve for two missing sides. Doesn't matter which one we start with. Which one do you want to start with? The hypotenuse? Okay, yeah, so we would end up using sine for that, yeah. So I'm still going to label the sides. Right, so with respect to 39 degrees, this would be the opposite side, and this would be the hypotenuse. So we'll set this up as sine of 39 degrees equals opposite over hypotenuse, so 11 over x. And then, just like we talked about yesterday, whenever we have x in the denominator, I'll multiply both sides by x first, and then divide both sides by the trig function. So we end up with x equals 11 over the sine of 39. And that gives 17.5 if we round to the nearest tenth.
So how do you figure out the calculator for your 11?
11 divided by the sine of 39. Yeah. Yeah, so let's try not to get in the habit of calling it sin and cos and tan, sine, cosine, and tangents. So, my hypotenuse now is 17.5. So now we want to solve for this side. So I'll use a different variable. I'll call it y. And now we have options. Since I know two sides, I could use the Pythagorean theorem to solve for this third side. Or we can set up another trig function. Which one do you guys want to do for this one? Another trig one? Okay. So now, with respect to this 39-degree angle, we probably want to use the exact number that we have, right? This 17.5 was actually, 17.47 something. So whenever we can, we want to use exact values. So I'm going to use the 11 in this case. So I'm going to use the opposite side, and now this will be the adjacent side. So opposite and adjacent is going to be tangent. So I can set this up as tangent of 39 degrees equals 11 over y. And just like we solved this one, y by itself, multiply y to the left side, and then divide by the tangent of 39. So 11 divided by the tangent of 39 gets us 13.6. So this side is 13.6, and we have solved the right triangle. Okay, we found all missing sides and all missing angles. Okay. Questions? All right, why don't you guys try number 8 here? could use 44. Yeah. Alright, did we get 44 degrees for angle Y, and then 19.5 for ZX, and 20.1 for YX? Questions? Alright. And let's flip over to the back. We're running a little short on time. So I am just going to do a couple of examples here. In numbers 9 and 10, it's still the same idea. We want to solve the triangle. But in both of these, I'm only given the right angle and then two sides. What's that? Yeah, that'd probably be a good idea. So, to find a missing angle, we need to use an inverse trig function. So again, it doesn't matter which angle we solve for. I'll solve for C first. I'll call that my x degree angle. So then with respect to this angle, this is the adjacent side. This is the hypotenuse. So I would use cosine. My setup would be cosine of x equals adjacent over hypotenuse. 14 over 22. Then to undo cosine, I take the inverse cosine of both sides. So these cancel out. And the inverse cosine of 14 over 22 is 50.5. So now, since I know this angle, I don't have to set up another trig function to find the other one. Right? Now I can just say, well, 180 minus 90 minus 50.5 will give me this angle. So that would be 39.5. Then, to find our missing side, we've got two options. We could use Pythagorean theorem or a trig function. Since we used trig functions on the last ones, I'll use Pythagorean theorem here. So these are my two legs, right? The 14 and the unknown side, and then 22 is the hypotenuse. So a squared plus b squared equals c squared. 14 and my unknown are the legs, so I'll just leave that as b squared. So we get 196 plus b squared equals 2 squared, 484. Subtract the 196 over. Get b squared equals 288. Then take the square roots. And whenever we have something that doesn't work out perfectly, we want to simplify it. Right? So the largest perfect square that goes into 288 is actually 144. Right? I mean, you may not recognize that right off the bat. You can do some guessing and checking in your calculator. What's that? Yeah, so it would be 144 and 2. So we'll say we can split this up into the square root of 144 and the square root of 2. And exactly, the square root of 144 is 12. So this would simplify to 12 times the square root of 2. And we have solved this triangle. Okay? Now, we're not going to have time to do any more examples, but let me at least point something out on the next couple of types of problems. For numbers 11 and 12, we have two right triangles that share a side. Okay, so in this one, the goal is to find side DE. Well, to do that, I'm first going to have to use this triangle here and find their shared side, and then use the shared side to set up another trig function in this one down here. Okay? So it's just setting up two trig functions. Same thing here. We would need to find the shared side first, and then use that again.